For each ordered pair, determine whether it is a solution to the system of equations y equals 2x plus 1, negative 5x plus 3y equals 8. So in order to determine, what we need to do is to take each of the values for x and y and plug it into both equations one at a time to see if it is a solution. In order for it to be a solution to the system, it must be a solution to both equations. So let's start with the example x being 5 and y being 11. So what we're going to do is take the first equation, y equals 2x plus 1, and substitute 5 in for x and 11 for y. So 11 equals 2 times 5 plus 1. So 2 times 5 is 10, and 10 plus 1 is 11. Since the right side equals the left-hand side, that is a solution to that equation, but it doesn't mean it's a solution to the system. We need to plug the 5 and 11 into the second equation, the negative 5x plus 3y equals 8. So again, we're going to replace x with 5 and y with 11. So negative 5 times 5 is negative 25. 3 times 11 is 33. And negative 25 plus 33 is 8. So again, since the left-hand side equals the right-hand side, this is a solution to the equation. Since 5 and 11 were solutions for both, then it is a solution for the system. Let's look at one more. Let's look at the ordered pair 0, 1. So x being 0 and y being 1. So again, we'll come to our first equation, y equals 2x plus 1, and substitute 0 for x and 1 for y. So that gives us 1 equals 2 times 0 plus 1. 2 times 0 is 0, and 0 plus 1 is 1. So this was a solution to the first equation. But again, it's not a solution for the system unless it's a solution to both equations in the system. So now we come to the negative 5x plus 3y equals 8. And again, we're going to substitute 0 in for x and 1 in for y. So negative 5 times 0 is 0. 3 times 1 is 3. And 0 plus 3 is 3. And 3 does not equal 8. So 0, 1 is not a solution to the equation. Therefore, 0, 1 is not a solution to the system. For each system of linear equations shown below, classify the system as consistent dependent, consistent independent, or inconsistent. So, if a system is consistent dependent, then it has an infinite number of solutions. If it is consistent independent, then the system has a single solution. If a system is inconsistent, then it has no solution. So let's look at this graphically and determine whether it's consistent dependent, consistent independent, or inconsistent. So in this case, line 1 is y equals 5/2 x minus 1. Line 2 is negative 5x plus 2y equals negative 2. So we're going to graph, or it's done for us in this case, the lines on the same coordinate plane. And we're looking for the points that each line have in common. So in this case, as you can see, line 1 and line 2 are the exact same line. One line is on top of the other. So therefore, we have an infinite number of solutions because every point on each of the lines is common to both lines. So we have an infinite number of solutions, which means our system is consistent and dependent. So again, because it's an infinite number of solutions, it's consistent and dependent. Let's look at the next example. So again, they give us two equations. The first one, y equals 1/2 x minus 4. The second one is y equals 1/2 x plus 2. And they've graphed those for us. And we know that these lines are parallel because their slopes are the same and their y-intercepts are different. How many points do these lines have in common? And of course, the answer is they have no points in common. Therefore, there is no solution to the system, which means the system is inconsistent and it has no solution. And let's look at the third example. So here they're giving us two equations. The first equation is y equals negative 2x minus 4. The second equation is y equals x minus 1, and they've graphed both of these on the same coordinate plane. So we're looking for what point or points they have in common. In this case, these lines intersect at a single point. So that means that our system has a single solution, which makes it consistent, independent. It has a unique solution, and that unique solution is the coordinates of that point, which would be -1, -2, because we went to the left one and down 2. Graph the system below and write its solution. So we have two equations, y equals 2x minus 2 and 4x minus 2y equals 4. I recommend writing these both in slope-intercept form to make it easier to graph. So the first equation is y equals 2 over 1x minus 2. Now the second equation we need to write in slope-intercept form. So we have 4x minus 2y equals 4. So we need to isolate our y. So we're going to move 4x from the left-hand side to the right-hand side by taking its opposite. That gives us negative 2y equals negative 4x plus 4. And then we're going to divide each term by -2. And that gives us y equals -4 divided by -2 is +2, or 2 over 1x. Then +4 divided by -2 is -2. So equation 1 is 2 over 1x minus 2, and equation 2 is the same thing. So we have the same line, so we know we're going to have an infinite number of solutions. So let's graph this. We start with our y-intercept, which is -2. And our slope is 2 over 1. So from our y-intercept, the rise is 2 and the run is 1. So now you're going to connect these points with a line. And again, the second equation is exactly the same. So we know we're going to have the exact same line, which means they have all their points in common. So we have an infinite number of solutions. Use substitution to solve the system. We have the equation 3x minus 5y equals 7. And the second equation is 2x minus 7 equals y. Here we're going to use substitution because we have y equaling 2x minus 7, which means in the first equation where we see y, we can substitute the quantity 2x minus 7. So I'm going to write the first equation, 3x minus 5y equals 7. And now in place of y, I'm going to substitute the 2x minus 7. So that gives me 3x minus 5 times the quantity 2x minus 7 equals 7. So now we're going to solve this like we normally do. We're going to start with the distributive property on the left-hand side. Negative 5 times 2x is negative 10x. Negative 5 times negative 7 is positive 35. And then we're going to collect our like terms. 3x minus 10x is negative 7x. And then isolate our variable. So we're going to subtract 35 from both sides. And that gives us negative 7x equaling negative 28. And then we're going to divide by negative 7. So this tells us our x value is 4. Remember, when we're solving a system, we're solving for all of the variables, in this case x and y. So how do we find out what y equals? We have two choices. We can either take equation 1 or equation 2 and substitute 4 in for x and solve for y. In this case, it'll be easier to take the second equation, 2x minus 7 equals y, and substitute the 4 in for the x. So that gives us 2 times 4 minus 7 equals y. 2 times 4 is 8, and 8 minus 7 is 1. So our solution for this system is x4 and y being 1. If you wanted to check your solution, we can take the other equation, the 3x minus 5y equals 7, and substitute our answers in for x. So this becomes 3 times 4 minus 5 times 1 to make sure that our answer is true for both. So 3 times 4 is 12. Negative 5 times 1 is minus 5. And 12 minus 5 is 7. So it is a solution that works for both of our two equations. So there are various methods to solve systems. We've looked at two already, graphing and substitution. And then third method is called either the addition method, or some people call it the elimination method. So let's go through this method. So the first thing that we do, we make sure that our x and y are on the same side, and on the other side of our equal sign would be our constant, which is the case for this particular example. Now we have 9x plus 6y equals negative 3, and 5x plus 6y equals 9. So if I were to add these two equations together just as they are, I would have 14x plus 12y equaling 6. Now my goal is to eliminate one of the variables. So in its current form, I can't do that. So sometimes I need to multiply one or both equations by something to make the coefficients of the x or y opposite. So what I do is I choose which of the two variables I want to eliminate. In this case, it's easier to eliminate the y, so I'm going to eliminate the y. Now, the first equation, 9x plus 6y equals negative 3, the y has a coefficient of positive 6. So in order for the y to be eliminated, the second y, or the y in the second equation, has to be negative 6. So what I'm going to do is multiply that second equation by negative 1. So since I didn't make a change to the first equation, that stays the same. 9x plus 6y equals negative 3. Now the second equation I multiply by negative 1, which gives me negative 5x minus 6y equaling negative 9. Now when I add the two equations together, the y value is eliminated, and that leaves me 9x minus 5x, which is 4x, and negative 3 and negative 9 give me negative 12. So I eliminated one of the two variables so that I could solve for the other. Now I divide both sides by 4, and x would equal negative 3. So remember, we're solving a system, so I need to know the values of x and y. So I take either equation 1 or equation 2, and I'm going to substitute negative 3 in for x. So I'm going to go ahead and choose equation 1 and substitute negative 3 in for x. So now this becomes 9 times negative 3 plus 6y equals negative 3. 9 times negative 3 is negative 27. So that gives me negative 27 plus 6y equals negative 3. I'm going to isolate my variable, so I'm adding 27 to both sides. That gives me 6y equaling positive 24. And now I'm going to divide both sides by 6. So y equals 4. So my solution would be negative 3, 4. Remember, your x value comes first. So let's look at our next example. Solve the following system. Negative 3x plus 5y equals 2, and negative 5x plus 2y equals 16. So again, what I would try to do first is see what happens when I add the two together. So negative 3 and negative 5 gives me negative 8, and 5 plus 2 gives me 7. So neither one would have been eliminated. So I need to choose which of the two variables I want to eliminate. Let's say I want to eliminate the x in this case. So I find a common multiple of 3 and 5. So a common multiple of 3 and 5 would be 15. So I need to make one of the coefficients positive 15 and the other one negative 15. So I'm going to start by multiplying the first equation by negative 5. So negative 5 times negative 3 gives me that positive 15x. Negative 5 times positive 5 gives me negative 25y. And negative 5 times 2 equals negative 10. Notice I multiplied everything by the negative 5. Okay, so now I need to multiply the second equation in order to make the coefficient in front of x negative 15. So I'm going to multiply by positive 3, because positive 3 times negative 5 gives me negative 15. Now you notice that your x's are opposite. So I go ahead and finish my distributive property. 3 times positive 2 is positive 6y, and 3 times 16 is 48. So now I'm going to add the two equations together, and my x is eliminated. Negative 25 plus 6 gives me negative 19y. And negative 10 plus 48 gives me positive 38. I'm going to divide both sides by the negative 19, and y would equal negative 2. So remember, we know our y value, but we have to find x. So in this case, I'm going to go ahead and take the second equation. Negative 5x plus 2y equals 16. And I'm going to plug negative 2 in for y. So I get negative 5x. 2 times negative 2 is negative 4. I'm going to isolate my variable, so I'm going to add 4 to both sides. So that gives me negative 5x equaling 20. And then I divide both sides by negative 5, and x equals negative 4. So my common solution would be negative 4. Remember, your x value comes first, negative 2. And again, you can always check your answer by taking your answer and plugging it in to the other equation, not the one that you just used, but the other equation. Two systems of equations are given below. For each system, choose the best description of its solution. If applicable, give the solution. So system A is x plus 2y equals 4, and negative x minus 2y equals negative 4. So again, what we're going to do is see what happens when I add the two equations together, if one of the two variables will be eliminated. Since I have x and negative x, I know that my x's will be eliminated. And in this case, I have a positive 2y and a negative 2y, and those will be eliminated as well. So on my left-hand side, I have no variables. All I have is 0. Now on the right-hand side, when I add 4 and negative 4, that gives me 0 as well. So what does that mean? Anytime we're solving, if our variables are eliminated, we check the validity of this statement. Is that true or not? Does 0 equal 0? In this case, yes, 0 does equal 0. Therefore, we have an infinite number of solutions. So anytime our variables are eliminated, we're either going to have an infinite number of solutions or no solution. System B, x plus 2y plus 6 equals 0, and negative x minus 2y equals negative 6. So remember, we want the x's and y's on the same side and our constant or that answer on the other side. So we're going to take the first equation, x plus 2y plus 6 equals 0, and move this 6 on the other side by taking its opposite. So now equation 1 will be x plus 2y equals negative 6. So I'm going to go ahead and write equation 2 right under it, which is negative x minus 2y equals negative 6. And again, before I multiply either equation, I'm going to see what happens when I add them together as they are. So in this case, again, the x's are opposite, so x would be eliminated. And again, in this case, the y's are opposite as well, leaving me 0 on the left-hand side of my equal sign. Now on my right-hand side, I have negative 6 and negative 6, which gives me a negative 12. So again, all my variables have been eliminated, so I look at this statement. Does 0 equal negative 12? And the answer is, of course not. So since this isn't a true statement, the system would have no solutions. Christine, the trainer, has two solo workout plans that she offers her clients, Plan A and Plan B. Each client does either one or the other, not both. On Monday, there were two clients who did Plan A and five who did Plan B. On Tuesday, there were 8 clients who did Plan A and 3 who did Plan B. Christine trained her Monday clients for a total of 6 hours and her Tuesday clients for a total of 7 hours. How long does each of the workout plans last? So let's start by looking at Monday. So on Monday, 2 clients did Plan A and 5 did Plan B for a total of 6 hours. Now on Tuesday, there were 8 clients who did Plan A and 3 who did Plan B for a total of 7 hours. So now we have a system of equations that we need to solve. So again, you determine, first of all, what happens if I add them together just as they are. 2 and 8 are 10, 5 and 3 are 8, so it doesn't do anything as far as eliminating one of the variables. So now we choose one of the two variables to eliminate. So I'm going to eliminate A. It doesn't matter, I just chose A. So in order for me to eliminate A, their coefficients have to be opposite. So I look for a common multiple of 2 and 8, which would be 8. So one of these coefficients has to be 8 and the other negative 8. Since the second one is already 8, I need to multiply the first one to make it its opposite, or negative 8. So I'm going to multiply by negative 4. So remember, you're multiplying everything. So negative 4 times 2 is negative 8a. Negative 4 times positive 5 is negative 20b. And negative 4 times 6 is negative 24. Remember, we don't have to change the second equation at all. And now I add the two equations together. And again, it did just as I planned. It eliminated the variable a. And negative 20 plus 3 gives me negative 17b. And negative 24 plus 7 is negative 17. So I divide both sides by negative 17. So b would equal 1. So it takes Plan B 1 hour to complete. Now I need to find out how long it takes A. So I choose either equation 1 or equation 2 and substitute 1 in for B. I'll go ahead and choose the second equation. 8A plus 3B equals 7. And remember, I'm substituting my answer 1 in for B. So that gives me 8A plus 3 times 1 equaling 7. So 8A plus 3 equals 7. We need to isolate the variable. So 8A equals 4, and then we're going to divide by 8. So A would equal 4 over 8, which is the same as 1/2, or half an hour. So it takes Plan A a half hour to complete, and Plan B 1 hour to complete. Two buses leave towns 471 miles apart at the same time and travel towards each other. One bus travels 9 miles per hour slower than the other. If they meet in 3 hours, what is the rate of each bus? So what I like to do is set up a table. So distance equals rate times time, or we can even say this as time times the rate equals the distance. Now we have two buses, bus 1 and bus 2. So it says one bus travels 9 miles per hour slower than the other. Well, we don't know how fast bus 1 is traveling, so we use x. And we know that bus 2 is traveling 9 miles per hour slower. So bus 2 would be traveling at x minus 9. Now, it says they meet in 3 hours. So they're both traveling for 3 hours. So the distance bus 1 travels is 3 times x, or 3x. Bus 2 travels for 3 hours at a rate of x minus 9. So the distance bus 2 travels is 3 times x minus 9. Now, it says the two buses leave towns 471 miles apart. So that means the total distance traveled is 471 miles. So the distance bus 1 travels, which is 3x, plus the distance bus 2 travels, which is 3 times x minus 9, equals the total distance of 471 miles. So we'll go ahead and solve by first using the distributive property. Positive 3 times x is positive 3x. Positive 3 times negative 9 is negative 27. We're going to combine like terms, so 3x and 3x gives us 6x. Isolate your variable, so we're going to add 27 to both sides. And then we're going to divide both sides by 6. So x equals 83. Now what does 83 represent? X. So what does x represent? It represents the rate of bus 1. So bus 1 traveled at a rate of 83 miles per hour. Now remember, bus 2 travels at a rate 9 miles per hour slower. So bus 2 travels at a rate of 83 minus 9, or 74 miles per hour.